Hey, Chemsters, this is Mrs. Vandelay bringing you more ether notes. How does that sound? We're in chapter 8.2, the physical properties of ethers. So, ethers are colorless compounds with usually pleasant odors. They have a lower boiling points than alcohols with equal number of carbon atoms. So, what is this first one? It looks like it has 4 carbons and an OH. So, that is yeah, you can name it 1-butanol. What about this other one? You should know how to name it. We just did this. It is, ready, diethyl ether. Now notice they have the same molecular weight. Why is that? Because they all have your 4 carbons. It has your, if I can do that in my head, looks like 9 hydrogens and 1 oxygen. So they all have the exact same molecular weight, but look at the major difference in their boiling points. Wow, butanol boils even higher than water does, but diethyl ether with the same molecular weights, the same London dispersion forces, boils at a much lower. It's a gas a little bit over room temperature. So what's going on? Why is that? All right, so why is that? Because alcohols, as I have right here, have hydrogen bonding. You see the O and the H there. But let me show you diethyl ether. Here's diethyl ether. Now, I know with my smartboard, stuff here, it's not exactly, but it is a bent molecule. This degree is about 105 degrees apart. All right, so it's definitely bent. All right, why is that important? Because here is my partially negative and down here is my partially positive. So there is a dipole. All right, so ethers show dipole. And what do we know about those intermolecular forces? That hydrogen bonding is a much stronger force than dipole. But I wanted to show you this structure. I know it's a little bit off, but it's better than nothing because here in 2D land, this looks linear. If it were linear, it wouldn't have any poles as such, okay? But it is a bent molecule, same bent as water would be bent, all right? And therefore, that oxygen is your partially negative area. So you do have dipoles. You have 2 poles, a partial positive and a partial negative, okay? All right, so write the structures for the following isomers, same form, a different structure, and arrange them, should be them, in order of decreasing boiling points first. So like I said, it might be helpful to draw them first. So go ahead and pause this and write them out and make your decisions. When you're done, come back. All right, well, here is my 3-methoxy-1-propanol. So here's my prop, and the alcohol takes a higher priority. So it's on the 1, and on the third carbon, on the third carbon is my methoxy. Over here, I have 1,2-dimethoxyethane. So here I have 2 carbons in the middle. Off of the first one is a dimethyl, or sorry, is a methoxy, and on the second one is a methoxy. And then this is a 1,4 butanediol. So I have 4 carbons, and then here are my 2 alcohols. Now, what do you notice about these structures? Guess what? They're going to have the same number of carbons, same number of oxygens, same number of hydrogens. If you want to draw on all your hydrogens, if you don't believe me, go for it. But that's what it's going to work out to be. So they have all the identical molar masses. So they have the identical London dispersions. So what do you think is going to go on here? So what kind of intermolecular forces does this one have? Well, I see a dipole-dipole here, and I see a hydrogen bonding here. So I labeled those right here for you. All right, what about over here? What do you see? I see, well, I have an O. Remember, it's bent like I showed you up here. All right, so what would this be? It's dipole-dipole. Why is bent important? Because that's why you have a region of partial negative. So maybe up here would be negative and down here would be negative or a positive. And what about over on this side? Well, I think I also have a dipole-dipole over on this side as well. So what do you see right here? I see an OH. That's definitely hydrogen bonding. What do you see over here? Oh, that's definitely hydrogen bonding. So what's going to be your lowest boiling point? All right. So order in decreasing boiling point. So, okay, I should maybe ask you this. Which is the highest boiling point? Well, I think you can all agree that this one would be. Why? You have two regions of hydrogen bonding. Well, then which one would be the middle boiling point? Probably this one. Why? Because you have one region of at least hydrogen bonding, which leaves this one to be number 3 because you have two dipole-dipoles. Okie dokies. Well, that's it for now. So we have one more section in chapter 8. So don't wait to be great. We'll see you next time. Bye-bye.